Hello, this is Math 2134 coming to you from the College of DuPage for the fall of 2020. And the title of this lecture is Pre-Calculus Review 1. We're going to be talking about calculus of a real variable, and that means we're going to be talking about the real number system, which of course is lined up with a number line. We have negative numbers this way, positive numbers this way, and the origin or zero is in the middle, and every real number is corresponding to a point, and every point corresponds to a real number. The real number that is associated with a point on the real number line is called the coordinate of that point. We will be using interval notation to describe many subsets. We can have finite intervals, which can be open, closed, half open, and that means half closed. So if we write, for example, parentheses -2, 1, that means these are the numbers that are between -2 and 1 on the number line, not including -2 and not including 1. A closed interval, for example here, the closed interval shown with a bracket, -1 to 2, is all numbers between -1 and 2, including the 2 endpoints. Here, the 1/2 is not included, the 3 is included, and here the -1/2 is included and the 3 is not included. These intervals can also be infinite in length. Infinity is not a real number, so you always have a parentheses following that. And here we have the numbers that are strictly greater than 2. Here we have the numbers that are greater than or equal to -1. Here we have the numbers that are less than 1, going all the way to minus infinity. We also consider exponents. So whenever n is a positive integer, we say a to the n means a multiplied by itself n times. So 2 to the 5th is the same thing as 2 times 2 times 2 times 2 times 2 equal 32. A zero exponent, like 7 to the 0, is always 1. 0 to the 0 is not defined. We can talk about 6 to the -2, and that means that the 6 squared is in the denominator, so that would be 1 over 36. Fractional exponents are defined in the following way. A to the 1 over n corresponds to the principal nth root of a. And a to the m over n is either the nth root, principal nth root of a to the m, or the nth root of a raised to the m power. And the same thing holds for negative exponents. You put things in the denominator. We have laws of exponents. If we multiply two expressions with the same base, you add the exponents. If you divide two exponents with the same base, you subtract exponents. We have product rules that work these ways and quotient rules that work this way. Here's a problem for you to do. In fact, here are 5 problems for you to do. I'm going to encourage you to give these a go. Anytime you've seen this symbol, you know what to do. You should pause the video, work the problem, and come back and we'll see how you did. Let's see how you did. So here, 4 times 3 is 12, and 2 plus 3 is 5, so this is 12x to the 5th. Here you're subtracting exponents. When you subtract the exponents, you get a common denominator, and this is going to be 2 over 4, so that is going to be 16 to the 3 over 4. And that's the 4th root of 16, which is 2, and then cubed, which is 8. Here you just multiply the exponents, and you get 36. Here you multiply the exponents and simplify the fraction so that there is no negative exponents and get y to the 4th over x to the 6th. And here you first of all turn things upside down, and then you multiply through on the exponents. Actually here I guess what we really did was just multiply through by the exponents, and then we simplify this, so the y cubed goes into the denominator and the x to the 1/2 goes into the numerator. Here's another set of problems for you to do. These involve radicals. You know what to do. Let's see how you did. You apply the 1/4 to each of the terms, and you end up with 2x y squared. Here you can multiply what's underneath the radicals first, and you get 36m to the 8th n squared, and then you raise each factor to the 1/2 power, and that at the end of the problem gives you 6m to the 4th n. And down here, what you can do is you can change it to a fractional exponent and apply the 1/3 power. Now, the 1/3 power of minus 27, and that really should be parentheses minus 27 whole to the 1/3, and that is going to be a minus. So this actually is a minus, even though it doesn't show it being separated very well. And the cube root of 8 is 2, so this is 3x squared over 2y. Sometimes we do things called rationalizing, either the numerator or the denominator. What we do is multiply by 1 to change the radical. We have to do this in some of our calculus calculations. Not because someone tells us to, because it's the only way to solve the problem. So here we start with this expression, but we multiply by 1 in the form of the square root of x over the square root of x. That's 1. That doesn't change the value. But in the bottom, that's going to give us the square root of x squared. And in the top, it's going to give us this. So that's going to be 3/2. X over x is going to be 1, so that is 3/2 the square root of x. Here is a similar thing. We write this using a radical. We multiply top and bottom by the square root of x. That is the square root of x over square root of x. We're multiplying by 1. Multiply across the top and bottom, and then simplify, and we get the square root of x over 2x as our answer. And sometimes we even do that in the numerator. Here we multiply top and bottom by the square root of x. We get multiplying by 1 here, and that's going to be 3 over 2x. But then we take the square root here, we get x, so the x's cancel. You get 3 over 2 square root of x. We also do algebra, as you've learned. Here we distribute the minus sign across first. That changes the sign of everything inside. Then we collect like terms. Like terms are terms that have the same variables and the same exponents. So when we combine the terms with x to the 4th, x cubed, x squared, x, and the constant, we get this as our final solution, combining like terms. Here we are going to simplify inside the parentheses first. And so we go to the innermost parentheses and we simplify here, and we get that that is going to be negative t squared plus t plus 3, and then we subtract and we collect like terms, and we have this as our final answer. Here are some problems for you to do. So perform the indicated operations. You know what to do. Let's see how you did. In the first problem, when you distribute the x squared across, and then you distribute the 1 across, you distribute across, and then you collect like terms, and you get this as your final answer. Here you distribute the x, and you distribute the y, then you collect like terms. Terms with the same variables and the same exponents. And this is what we get as our final answer. The only term that got consolidated was the minus 1/8 xy and the minus 1/8 xy to give minus 1/4 xy. And down here, when I distribute this, I will get, in both times I will get these expressions, and then I'll realize that e to the 0 is 1. And so these will cancel one with another, and that will be 1 plus 1 is 2. This will be continued in 2134, lecture 3.1. See you then.